Morse code prosigns or procedural signals are special dot-sequence symbols that do not represent written or printed alphanumeric or punctuation text characters. Mastery of prosigns and their usage is an important part of becoming a fluent telegraphist. Morse code prosigns are special symbols that have particular functions, such as indicating changes of transmission communications protocol status, and indicating text or page white space formatting. These special Morse prosign symbols, although preceding modern teleprinter and computer character set control characters by many decades, play a role similar to the control characters found in modern computer and teleprinter character set codes such as the Baudot, Murray, ITA2, ASCII, Unicode and diptych codes. Morse code prosign symbols have been used by telegraphists for over 140 years, predating modern character set code control characters by many decades. Traditionally, Morse code is encoded or sent manually by telegraphists using hand-operated telegraph keys and decoded or copied as the Morse signals are received by ear in real time. Morse prosigns constitute unique dot-sequence code symbols separate from those of normally written alphanumeric and punctuation Morse character symbols and have the same status as the normally written symbols. Although included in the transmitted Morse symbol data streams during normal keying operations, Morse prosigns are never explicitly written or printed upon reception either by hand or by typewriter. For illustrative and learning purposes, Morse prosign symbols may sometimes be displayed in a special delimited alphanumeric character group form. Nevertheless, prosigns are actually defined uniquely by the corresponding dot-sequence symbols and not by the delimited characters used for illustrative display. In fact, there might be several different delimited character groups that might possibly correspond to a unique Morse prosign symbol. The delimited character groups are for illustrative purposes and have no intrinsic meaning beyond being a memory aid. Illustrative displays of prosigns are comprised of specially delimited groups of alphanumeric Morse characters that, when sent, run together without normal 3-dot duration inter-character spacing, serve to comprise the unique prosign symbols. Normal Morse inter-character spacing is 3-dot durations. Conversely, the concatenated Morse characters illustrating prosigns are separated by only 1-dot duration. The sound of concatenated character groups used to form the unique prosign symbols is markedly different from the sounds of the individual concatenated characters themselves. The most important characteristic of prosigns are thus the unique sounds of the prosign symbols, not the illustrative character groups. Illustrative written delimitation of the character groups concatenated to create prosign symbols is effected by specially annotating the otherwise normal-looking groups. Common annotations used to delimit prosign character groups are either an overline extended over the character group or a set of angle brackets surrounding the character group. Here represents the dot-sequence symbol, which can be verbalized as the sound. Although prosign symbols are unique, concatenated character groups representing prosign symbols are not unique. Several such character groups might possibly be used to represent each unique prosign symbol. For example, the unique prosign symbol here represented by could alternatively be written as. The grouping is simply the most common way of illustrating the formation of this unique prosign. Another example of a prosign is that indicates the white space required to begin a new paragraph. This new paragraph prosign is most commonly illustrated by the concatenated characters B and T representing the unique dot-sequence that can only be uniquely verbalized as the sound. Alternatively might be illustrated as, or. It is, however, the sound that is unique to the prosign. As proficient telegraphists memorize the sounds of alphanumeric Morse characters rather than dot-sequences, telegraphists should also memorize the unique sounds of the prosigns, rather than their dot-sequences or their corresponding illustrative concatenated character groups. Morse prosigns and modern keyboard operations. Morse code is over a century old. Fluent Morse code telegraphists still enjoy sending Morse code and the traditional Morse prosigns using manually operated mechanical keys or electronic keyers. Although Morse code is no longer used in commercial practices, the use of hand-sent Morse code seems to be growing among amateur radio operators, even though Morse proficiency is no longer required to obtain an amateur radio license. As intrepid sailboat sailors, In the modern age of the powerboat, yearn for the heel of sailboats in the wind, there are those who send Morse code by hand in the modern age of the Internet. Nevertheless, some will mix modernity with Morse and choose to send Morse with keyboard-operated software applications rather than telegraph keys. The following paragraphs address difficulties encountered when mixing modern keyboard-operated computers with century-old Morse code Prosigns. Modern keyboard-operated teleprinter and computer character set codes, such as the Baudot, Murray, ITA2, ASCII, Unicode and diptych codes, use fixed-length symbols while Morse code uses bandwidth-efficient variable-length symbols sent by telegraphists using hand-operated mechanical telegraph keys, which permits creating Morse Prosigns by simply concatenating existing Morse symbols. This concatenation is achieved by simply pausing for only one dot duration between the concatenated characters instead of a normal 3-dot duration pause between non-concatenated characters. Modern fixed-length keyboard-generated symbols do not allow such concatenation, instead often requiring simultaneous multi-key actions to generate control characters. Although created by Samuel Morse and Alfred Vail in the 1840s, without benefit of the modern 1940s-era information theory concepts of Claude Shannon, the bandwidth efficiency of variable-length Morse code symbols is readily understood in terms of Claude Shannon's modern-era source coding techniques and Lempel's if codes. Modern teleprinter and computer keyboards contain so-called function keys that generate the corresponding fixed-length alphanumeric, punctuation and control characters symbols dictated by the given character set code. Function keys generally represent non-written code symbols and include keys labeled as Alt, Ctrl, Enter, Shift, Tab, F1, F2, F3, etc., or simply left unlabeled as is the spacebar function key. Actuating many of these control functions also requires simultaneous multi-key actions. Striking keys on modern teleprinter and computer keyboards generates a single fixed-length alphanumeric, punctuation or control character symbol, and providing no capability to send run-together variable-length symbols like Morse Prosigns. Additionally, many of the built-in control characters of the modern character set codes generated by keyboards are unrelated to traditional variable-length Morse Prosigns. Because of this, Morse operators using keyboard-operated computer applications often encounter difficulties attempting to send correctly formed Morse Prosign symbols and may also encounter incorrectly formed Prosign symbols sent by other keyboard operators. An example of the difficulties encountered by Morse operators using keyboards rather than telegraph keys to send Morse Prosigns is the use of the keyboard key labeled either Enter or New Line. Depending upon the application, striking the Enter or New Line key produces the same result as the older carriage return line feed key sequence, which typists execute manually on teleprinter or typewriter keyboards. The common multiple key manipulations used with teleprinters and typewriters has the same effect on printed text formatting as the traditional Morse New Line Prosign symbol sequence. Unfortunately, most computerized Morse applications do not generate the Morse Prosign when the Enter or New Line key is struck, and most current Morse computer applications do not respond to the Morse Prosign by generating a new line. The same is true for many of the other Morse Prosign symbols, such as the new paragraph Prosign and the new page or message separator Prosign. Corresponding single keys for most traditional Morse Prosigns are not found on modern computer and teleprinter keyboards. Operators who choose to use most keyboard-operated computerized Morse software applications should realize that keying characters in sequence does not concatenate them. For example, keying the character B followed by the character T will not generate the traditional Morse Prosign. As noted in following paragraphs explaining the table of Morse Prosigns, to alleviate some of these difficulties, certain keyboard-operated computerized Morse applications and products using single-line displays have hijacked the use of a couple of mathematical symbol keys on modern keyboards to represent two of the traditional Morse Prosigns. Because of these computer keyboard Morse software application limitations and omissions, operators sending Morse from keyboard-controlled applications rather than telegraph keys will encounter difficulties creating traditional Morse Prosigns. Keyboard Morse operators may work around these difficulties by connecting a standard telegraph key into the keying line beside the computer keyboard application interface and intervene during keyboard sending by manually operating with the standard telegraph key to transmit traditional prosigns. This workaround, however, defeats the convenience of using a modern keyboard. None of these difficulties actually prevents the development of Morse software applications capable of sending traditional Morse prosigns. For example, application developers might utilize one or more of the anonymously named function keys labeled F1, F2, etc. to actuate traditional Morse prosigns under program control. Likely because of the limited commercial market for such application programs, this currently does not seem to be the case. And so, keyboard Morse operators may be unable to correctly send most traditional Morse code prosigns and may hear improperly formed prosigns sent by keyboard Morse operators. When purchasing keyboard-operated computerized Morse software applications, customers should first determine if the application handles Morse prosigns appropriately to their needs. Fluent Morse code telegraphists enjoy sending Morse code and traditional Morse prosigns using manually operated mechanical telegraph keys or electronic keyers. Aspiring high-speed fluent Morse operators must not only master standard Morse alphanumeric and punctuation symbols but must also master the use of traditional Morse prosigns as described in the following table and explanatory paragraphs. Table of Morse prosigns. The following table lists the 14 Morse prosigns, ordered alphabetically by their most commonly used concatenated character group. Although each prosign symbol is unique, the delimited character groups listed in the first column of the table are not unique, but are the most common character group representations. In fact, different groups of concatenated characters may represent the same unique prosign. The delimited concatenated characters in the first table column have no intrinsic meaning and are shown strictly for illustrative and alphabetic indexing purposes. When forming prosigns by telegraph key, the delimited group characters are separated by only one dot duration, not the normal Morse 3 dot duration inter-character spacing. The dot dash sequences shown in the second column titled code symbol comprise the unique dot dash sequence definition of each prosign. Morse prosign symbols have their own unique sound, different from the sounds of all other Morse characters including those used to illustrate the prosigns. And so, as with all Morse characters, in order to handle prosigns at high speed, the unique symbol sounds need to be memorized, not the character groups of the first column. A single exception to this uniqueness is the alphabetic character K, which is used alternatively as a prosign. The normal alphabetic character K is only interpreted as a prosign, illustrated here as K, when sent alone at the end of a transmission. Attention prosigns, and equals. In Morse code, the so-called attention prosigns are used to attract the attention of all stations that may be monitoring or listening to a communications channel. The attention prosign is used when a transmitting station wants all monitoring stations to be alert and to listen carefully for an imminent important message or transmission. Upon hearing, receiving stations should be prepared to copy down or record everything that follows. May be interpreted in English as, copy this. The distress prosign is a distress signal used only in emergency situations to draw immediate attention and to request immediate help, either to save lives or to protect the imminent destruction of significant property. SOS may be interpreted in English as save our souls. Since early in the 20th century, the radio frequency of 500 kHz has been an international calling and distress frequency for Morse code maritime communication. Prior to the adoption of the distress prosign as an international Morse distress signal in the early 1900s, the Marconi Company used the signal CQD as a Morse distress signal. The distress signal CQD was not a prosign per se, rather it was a special Marconi code signal comprising the separate non-concatenated characters C, Q and D. The use of CQD was phased out in favor of around the time of the RMS Titanic sea disaster, and now for over 100 years, the Morse prosign has been used under several issues of the safety of life at sea or SOLAS convention regulations as a worldwide international Morse code distress signal. Under pain of criminal offense for misuse, the transmission of the prosign is only permitted to attract attention when life or property is endangered. In this regard, the Morse code prosign has the same significance as the Mayday distress signal used with voice communications by radio. Equals white space prosigns, and equals, with formal written Morse messages. White spaces are the line spaces appearing on a page delineating either a new line, a new paragraph, or a new page. Unlike informal Morse conversation, with formal written message procedures, the three Morse prosigns, and are used on transmission to indicate the presence of, and on reception to initiate the creation of, white space text formatting of the written or printed text on the page, text file, or video screen where the message is displayed. With informal Morse conversations, which are often carried out mentally rather than formally written, the new paragraph prosign is typically only used to provide operators with brief pauses for gathering their thoughts, and to perhaps jot down short notes. Such informal Morse conversations are often referred to as copy encode in the head. Although the message separator prosign is quite often used informally by amateur radio operators, its use is unwarranted in casual informal Morse conversations. The message separator prosign is superfluous to informal Morse conversations unless the information being transmitted actually requires explicit inter-message separation to enhance understanding and message handling. Upon reception by telegraphists, these three white space prosigns, and enable the creation of highly human legible documents. The formal use of these three prosigns in creating white space document legibility is detailed as follows. The new line prosign indicates a new line. The new paragraph prosign indicates a new paragraph. The end of message prosign indicates a message separator. Historically, formal record traffic Morse messages were typewritten in high volumes by professional telegraphists onto long paper rolls, or fan-folded, page-serrated, paper stacks, which were fed through typewriters rather than having telegraphists continually insert separate sheets or pages into the typewriter to accommodate each message. Multiple messages were often sent by traffic handlers during long traffic transmission sessions, and efficient workflow demanded formal separation of messages and transmissions by the prosign and sufficient message separation white space on paper to enable physically tearing apart messages for actual delivery to third parties on reception. Historically, the message separator prosign indicating end of message was used to initiate the creation of this inter-message white space on the page. Telegraphists often turned up a completely new page on a continuous paper roll feed for each message. When typing or writing on individual message forms such as the ALL radiogram form, a new blank message form is actually torn from a pad of blank forms upon hearing the prosign. The prosign may thus be interpreted as a message separator between messages or as the end of message marker on a per message basis. Early telegraphists apparently saw the need for, and created, only the three white space prosigns, and described previously. On the other hand, modern computer character set codes and keyboards contain even more white space control characters such as the space bar and the tab key. The space bar on modern keyboards creates the standard fixed space between words and generates the most widely used teleprinter and computer keyboard white space control character symbol, sometimes known as the blank character. Since traditional Morse code symbols are of variable width, there can be no Morse prosign equivalent to the fixed-length white space blank character symbol created by the space bar. Traditional telegraphists create spacebar white space blank characters between words by simply pausing for the minimum number of prescribed dot durations required for Morse code inter-word spacing. There is no Morse code equivalent for the tab function key of modern keyboards. Unwritten Morse code white space prosigns, and enable the creation of highly human legible documents and predate the use of the somewhat arcane inline printed mathematical symbols implemented in some microcomputer-based Morse encoder-decoder products. Equals keyboard math symbols used to generate and equals, normal page-oriented white space line space formatting cannot be used with single-line electronic display systems, since it is impossible to space down page on non-existent pages to create white space lines on a single-line display. Sometimes keyboard-operated systems utilizing single-line displays instead generate or render the new paragraph prosign using the mathematical equal symbol found on keyboards, and generate or render the message separator prosign using the mathematical plus symbol found on keyboards. apparently the representation of the new paragraph and message separator Prosigns by means of the seldom used mathematical equal and plus symbols and keys initially appeared with the advent of keyboard-operated electronic Morse code encoder-decoder devices utilizing single-line displays. Examples of such devices are the MFJ Enterprises models MFJ461 and MFJ462B Morse code reader products. Since traditional whitespace formatting of pages according to the received Prosigns creates more human-legible documents than computer-based methods that utilize inline insertion of printed mathematical symbols, Morse code software application developers should include an option for users to request either the traditional highly legible whitespace formatting or, at the user's discretion, the arcane computer-oriented inline printed mathematical symbols. Turnover Prosigns, and turning over a communications channel is the change in communications protocol transmission status that occurs when a transmitting station turns over or releases transmitting control of a communications channel to another station. The general turnover prosign is traditional and is identical to the alphabetic character symbol for the letter K, which is interpreted as a prosign only when sent alone at the end of a transmission. This is the only Morse code prosign symbol that is identical to a normal written text character. Thus, when sent alone at the end of a transmission, the alphabetic character symbol for the letter K is taken to indicate a general channel turnover change in communications protocol status and literally means go ahead anyone, or over to anyone. The specific turnover prosign comprised of the run together or concatenated letters K and N indicates a specified channel turnover or change in communications protocol status literally meaning go ahead only, or over to you only, when the sending operator wishes a reply from only the currently specified receiving station and does not wish replies from any other stations. The end of contact turnover prosign is usually sent in lieu of the prosign or the prosign at the very end of the last transmission from the transmitting station to indicate the termination or end of a particular contact between two stations, thus turning the communications channel over to other users. The prosign may be interpreted in English as, this station will be silencing key. Often when terminating a contact with the prosign, a transmitting station may continue listening on the communications channel for calls from other stations. The closing station turnover prosign is sent by operators just before finally quitting the communications channel, and turning off their receivers. Thus, for example, when terminating a contact and closing their station, a transmitting station will often end the last transmission with the double prosign sequence, which can be interpreted in English as silencing key and closing. The fast break turnover prosign is used at any time within a conversation or contact between two stations as a fast turnover to indicate that the sending station is turning over the communications channel quickly to the specific receiving station without taking the time to transmit the identity of either the sending or receiving station. This prosig may be interpreted in English as the word break. Full break in turnover, also known as QSK operation, is the fastest and most efficient turnover technique. QSK operation is a technique wherein each station is equipped with the radio transceiver hardware technology necessary to enable listening between transmitted dots and dashes. This so-called QSK hardware technology creates the opportunity for a receiving station to quickly interrupt a sending station. Station operators equipped for full break-in operation usually send the Q-code signal QSK during the first transmission of a Morse conversation to inform the receiving operator that the transmitting operator can listen between dots and dashes. When equipped for full break-in or so-called QSK operation, stations can easily interrupt each other's transmissions by momentarily pressing their telegraph key while the other station is still transmitting. At this point, the interrupted station pauses and transmits a single prosign and pauses again to listen for what the interrupting station sends. Using hardware-enabled full break-in interrupt technology together with the Morse prosign enables fast and fluid two-way telegraphy communications similar to normal human face-to-face voice conversations. In practice, none of these turnover prosigns are ever written or printed. Miscellaneous prosigns, and the wait prosign is used by a transmitting station to request that receiving stations wait for further instructions from the transmitting operator. Often the prosign may be immediately followed by a numeric character such as 1 or 3 to indicate the approximate number of minutes that the sending operator wishes the receiving operator to wait. The wait prosign is often used by Morse code amateur radio net control operators when acknowledging specific stations checking into a Morse code network. Normally the receiving station being asked to wait will immediately respond to an request by sending the single understood prosign. The understood prosign is intended to be used by receiving operators to respond to requests from a transmitting operator. For example, a transmitting operator may request the receiver to wait for 3 minutes by sending 3 and the receiving operator would respond immediately with the single prosign. In practice, however, many Morse code operators will more commonly acknowledge requests with a single ordinary alphabetic character R, which is a short form of the voice response Roger, or received, or with the single alphabetic character C, which is a Morse code short form for confirmed, or yes. Your next Japanese prosign, when sent by a Morse code operator, indicates to the receiving operator that the sending operator will be immediately shifting the communications protocol from International Morse code symbols to Japanese Weiban code kana symbols and to interpret all of the symbols that follow as Weiban code symbols and not Morse code symbols. The symbol may thus be interpreted in English as next Japanese. Prosign may also be shown as. The prosign appears in both Morse where it means understood and in the Weiban code where it means shift to Morse code. When sent by a Japanese Weiban code operator, is a prosign symbol in the Japanese Weiban code that indicates to the receiving operator that the sending operator will be immediately shifting the communications protocol status from the Japanese Weiban code kana character symbols to International Morse code encoding and to interpret all the symbols that follow as International Morse code and not the Japanese Weiban code kana symbols. The Weiban code is a special form of dot-dash symbol code created by the Japanese, which encodes the modern-era Japanese kana or katakana characters. The two prosigns and are used to signal a communications protocol status change from the Japanese Weiban code to Morse code and vice versa. Note that the kana characters are a modern form of writing Japanese language and are not the ancient Oriental pictographic kanji characters used in traditional Oriental, Chinese, Korean, and Japanese writing. Error prosign, the error prosign symbol indicates a previously sent error and is comprised of a series of 6 to 8 concatenated dots or run-together alphabetic letter E symbols. This error prosign symbol indicates an accidental error in transmission that, once sent, has been almost immediately recognized by the sending operator. When the error prosign is sent, it is immediately followed by the corrected information text. When formally writing or typing a message, the receiving operator then deletes the erroneous text and replaces it with the corrected text. For illustrative or instructive purposes, this symbol may be written or shown as 6 or more run-together E letters with overliners E, or as a series of 6 or more E letters surrounded by angle brackets as or as the shorter delimited form. The number of E characters concatenated to indicate an accidental error must be more than 5 so that it is not taken to be any of the written alphanumeric characters I, S, H or numeral 5. This error prosign symbol comprising a concatenated sequence of 6 or more dots is never written down by receiving operators. This error prosign signals an upcoming correction to the previously transmitted message text, that is a change in communications protocol status. Other non-prosign techniques are sometimes informally used to indicate such accidental errors in transmission. Some operators indicate errors by sending a few sequential question marks, a sequence which would not often normally appear in regular written text messages. The sequence of 4 or more question punctuation marks is then followed by the correct text. Alternatively, some operators indicate an accidental sending error by transmitting a few well-spaced out dots, the unusual broken rhythm indicating that an error was accidentally sent and then followed by the correct text. In formal message traffic handling, there are a further set of detailed procedures and abbreviations for locating errors and getting fills within formal messages which, for those interested, are fully described in the message handling documentation found in the ALL radiogram ALL National Traffic System Practices and Procedures documentation. This documentation is available in print or online from the American Radio Relay League. Prosigns in casual use Unlike formal written record message handling or participation in either Morse code tests or Morse code high-speed copying contests, casual contacts by amateur radio operators do not require memorizing all of the prosigns or attaining great skill in use of all of the 14 prosigns in the preceding table. This is because, with most casual amateur radio contacts, the full text of conversations is usually never written down or recorded. Instead, operators casually copy Morse signals mentally while jotting down only a few important facts such as names and locations, etc. With such casual contacts, there is no need for white space formatting prosigns, or initiating specific message handling communications protocol changes. Of the 14 prosigns listed in the preceding table, only 3, namely, used to turn transmission control over to other parties, to provide pauses between thoughts in the error prosign, are all that are necessary for casual contacts. With a little more experience, the use of the and prosigns can be entertained. Finally, just in case there is ever an emergency encountered during operations, the sound of the prosign should be memorized. And so for casual amateur radio Morse code operation, only these 7 prosigns, namely, and of the 14 Morse prosigns tabulated in the preceding table, need ever be committed to memory. The remaining 7 prosigns of the preceding table can be safely left to professional commercial or hardcore amateur radio traffic telegraphy message handlers who must handle formal written record messages. Example of an informal telegraphy conversation: sensible and efficient informal Morse code conversations between operators involves more than simply knowing the alphanumeric and punctuation characters. Skilled operators must at least also know and respond to at least 7 common Morse code prosign symbols. In addition to Morse code characters and prosign symbols, there are also internationally agreed communications protocols or patterns of communication, international Morse code abbreviations, and codes such as the ACP131 codes like the Q code, Z code, RST code, and commonly encountered numbers from older telegraph-era codes such as the Phillips code to assist with efficient and quick Morse code conversations. In the following example, an informal Morse code conversation between stations with the call signs X1AA and X2BB is depicted. In the following conversational example, the mathematical symbol equal representing the prosign is shown written in line, as might occur if a single-line display automated software application were encoding and/or decoding the Morse code. The prosign symbol is actually sent along with the other Morse code information-bearing characters, but these prosigns are not normally written down by the receiving operator. If writing while copying the signal, the receiving operator merely skips down a line or two upon hearing the prosign, creating the appropriate white space. Often, as depicted in the following example, with short informal Morse code conversations, operators copy mentally in their heads without formally writing or typing anything. In the case of mental copy, the presence of the prosign, indicated by the equal signs in the example, instead of being used to trigger white space in a written record, is used to simply provide the receiving operator with a short mental pause to digest what was just sent, and perhaps to jot down a short note about it. X1AA, CQ1AA X1AAK, calling anyone, this is X1AA, over, go ahead anyone, X2BB, X1AAD X2BB X2BBKN, calling X1AA, this is X2BB, back to you only. X1AA, X2BBDE101AA equals GA Dr. OMUR rest 599 hours equals QTH Timbuktu equals OP is John equals HW. X2BBDE101AAKN, we note here again, the equal signs represent the or prosigns, as for example in single-line display computerized Morse readers. Good afternoon dear old man, you are RST 599 here. Note: RST 599 means very readable, very strong signal, very good tone. I'm located in Timbuktu, the operator is John, how do you copy? Go ahead only X2BB. X2BB, X1AAD X2BB equals TNXFBRP T drive OM John you are 558 equals QTH Himalaya equals name as Yeti equals X1AAD X2BBK. Thanks for the fine business report dear old man John. I read you 558. RST 558 means, very readable, adequate, low-strength signal, good tone, I am in the Himalayas, my name is Yeti, go ahead anyone. Note sending K alone as a prosign without the run together N invites other callers to break in. X1AA, X2BBDE101AA equals OKTNXQSO drive Yeti equals 73 ESHPECUAGN102BBDE101AAK, OK, thanks conversation QSO, dear Yeti, best regards Phillips code and hope to see you again. Go ahead anyone. X2BB, X1AADX2BB equals UTCUAGN73X1AADX2BBSK, Roger thank you see you again best regards. Signing off. SK, X1AA, EE, often, a couple of dits might end an amateur radio Morse conversation or contact. This traditional Morse code idiom resembles the archaic English pip-pip. X1AA and X2BB are representative amateur radio call signs identifying each of the parties to the Morse code conversation or contact. This example conversation, with channel turnovers initiated by each transmitting party sending the or the prosigns between transmissions is slow, awkward, and somewhat stilted when compared to normal face-to-face two-way voice conversations where the parties can actually interrupt each other. Such stilted Morse code conversations may be avoided and communications may be facilitated and rendered similar to normal human face-to-face voice conversation by using a technique known as full break-in or QSK. QSK operation is a technology and protocol wherein each station is equipped with the hardware capability of listening between dots and dashes, thus enabling interruptions by the other party similar to face-to-face voice conversations. If both parties are equipped with the hardware technology for full break-in interrupted operation, then stations may break into another's transmission at any time by momentarily pressing their telegraph key. Upon interruption, the interrupted station simply stops sending and transmits a single prosign indicating go ahead to the interrupting party and then waits for the interrupting party to send. Using full break-in QSK technology together with the single prosign creates a normal fluid conversation style. Highly fluent telegraphists utilized QSK operation to smoothly facilitate two-way Morse code communications. Example of a formal telegraphy record message, traffic handlers are Morse code operators who originate, send, receive, relay, record and deliver or handle so-called formal recorded text messages for relay and ultimate delivery to third parties. Morse record traffic handlers may be radio amateurs or paid professionals such as ships radio operators or military radio operators who send or relay radiograms on behalf of third parties. Regulations often require that a record of third-party traffic be retained by the sending and relaying stations for a reasonable period. Hence, such formal third-party messages are often called record traffic. These formal records of third-party traffic radiograms are usually handwritten, or typewritten either on paper or typewritten into a word processing file so that a more or less permanent record of the radiogram is available to be kept on file for future reference in case authorities wish to review the record traffic for their legal recollating purposes. In North America, amateur radio operators are permitted to handle such third-party record traffic as a non-profit public service. Such traffic handling on behalf of third parties by amateurs is actually forbidden by law or regulation in much of the rest of the world outside of the Americas, where most message relay service has been reserved for government-authorized monopoly-licensed corporations or governmental agencies such as local PTT authorities. The United States National Ham Radio Organization, known as the American Radio Relay League, and its Canadian counterpart, Radio Amateurs of Canada, publish manuals that standardize traffic handling procedures for such third-party record communications. These manuals may be downloaded from links at the ALL Internet website under the subject National Traffic System or NTS. The word relay in the name of the ALL is a relic of the original organizational purpose of the American Radio Relay League. When Morse code record traffic handlers receive a formal record message for relay or for ultimate delivery to a third party, they do not write or type prosigns explicitly. Instead they take the page and text formatting or transmission communications protocol actions indicated by the Morse prosigns to format the recorded message on the page, text file, or video screen. For example, when hearing the attention prosign CT, the operator who, until hearing the prosign, is merely listening without writing or typing, will begin writing or typing all that comes after the prosign, immediately expecting a text message header to follow. When hearing BT within a message, the traffic handler creates white space by beginning a new paragraph on the page. When hearing the prosign AA within a message, the traffic handler spaces down one line on the page. Upon hearing the prosign AR, the operator stops writing down or recording the current message text and prepares a new page or just spaces down several lines to a new part of the page in preparation to copy a subsequent message. An example of a typical record traffic message, sent in the ALL radiogram format, first is heard by the operator, illustrated in the following Part A paragraph, which explicitly includes all prosigns that are included in the data stream as well as the record text, and, secondly, in the following Part B paragraph, which illustrates the message as actually recorded by writing or typing the message on paper or into an electronic text file, without explicitly written prosigns. The second Part B paragraph illustrates the appropriate white spaces created by the receiving operator in response to the white space, attention and message separator prosigns sent by the transmitting operator. Part A, Morse code message data stream is actually transmitted, including prosigns indicated by the angle brackets. NR2RHXEVE9ZK10 Ottawa 1812-23-14 Joe Jackson 123 Henry Street, India, Florida, 32900 will meet you at station 1500 hours X best regards Pete. Part B, message as recorded on paper with white space text formatting rendered in accordance with the received prosigns. NR2RHXEVE9ZK10 Ottawa 1800 December 23, 14. Joe Jackson, 123 Henry Street, India, Florida, 32900. Will meet you at station 1500 hours X best regards. Pete. The two layouts of the same message as exhibited in the preceding paragraphs illustrates, in part A, the continuous data stream of Morse code symbols as received in real time and, in part B, the white space formatted text messages recorded on the page, text file, or electronic display where the permanent record of the message will be recorded for future reference. The first line in this formal message is the so-called header and contains somewhat arcane details of ALL radiograms that are only of interest to experts. The address lines illustrated below the header line are separated by two lines from the header as indicated by a new paragraph symbol prosign. Each line of the address information is separated from the others by a one-line space indicated by the new line prosign symbols. The address is then separated from the main text of the message by a two-line space new paragraph symbol. Finally, the signature line Pete is separated from the main body of the text by two lines indicated by another prosign. Comparing the two message layouts illustrated under the preceding Part A and Part B paragraphs, readers will note that the protocol change prosigns and in the Morse code data stream of Part A indicate only changes in transmission protocol status and so do not explicitly appear in the Part B recorded message layout. The leading prosign, usually interpreted as copy this, alerts the operator to pay attention and to begin writing or recording a new message text. The message separator prosign sent at the end of the message is interpreted as end of message, or new page, and alerts the operator to stop writing or typing message text and to prepare a new page or a new place on the page for the next message. Readers may note the traditional ALL radiogram style use of an X character in the main text of the formal message. Here the character X is simply used to indicate a so-called full stop, which is equivalent to the period punctuation mark in normal writing. Typically, standard punctuation characters such as commas, periods and question marks are traditionally not used in Morse traffic handling. Instead, such punctuation may be simply spelled out as words to ensure accuracy under noisy communications conditions. Sometimes the period or full stop may be sent as the spelled out word stop rather than the letter X. It is also traditional in Morse code record traffic to spell out the word query rather than to send the punctuation mark symbol ? Further details of traditional Morse code record traffic ALL radiogram handling procedures and practices may be found in the ALL National Traffic System documentation, which is available in print or online from the American Radio Relay League or ALL. See also, 500 kHz, ACP-131, Amateur Radio Net, ALL radiogram, ASCII, Baudot code, brevity code, carriage return, character set, control character, continuous wave, CQD, CW operators, distress signal, enter key, ABCDIC, high-speed telegraphy, ITA2, line feed, Mayday, Morse code abbreviations, Morse code, Murray code, National Traffic System, New Line, Phillips code, procedure word, Q code, Radioactive 1912 radiogram RMS Titanic rest code, SOS, spacebar, telegraphists, telegraph key, telegraphy, teleprinter, Unicode, whitespace character, whitespace, Z code. References